All right. So, where was I? Yes, let's go to my notes. Like last time I was looking at kind of like the I read this very nice article, and I was kind of like looking at the general kind of architecture of my neural network. I mean, not really the entire architecture, but just two main things, like the board state, like the representation of this S right here, because that was like quite complicated for BumperCoins. Like it was like set of like several image planes. Oops, how do I move? Or wait, no, yeah, I just used my arrow. Right. So like the input was like, yeah, the input shape was like five image planes. Like the top two image planes were like the current player's turn. Like it's like the player who the neural network wants to like assign a policy distribution, a policy for, a policy being like a set of moves with some weights attached to them. And yeah, so basically the top two planes are like kind of specify like which perspective, like our the perspective that we are the perspective. Actually, wait, why am I? I'm not listening to any music, but whose perspective? Like the current player. And then the bottom two planes, I mean the subsequent two planes are kind of the same thing except for the other player. Now, like in these batches of two planes, like the first one is referring to like the king coin, right? Like everything is discretized. All the coins are kind of rounded to like the nearest cell that they belong to, and then like the entry for that coin is its health. So we're kind of encoding all the information about the game state, but we're kind of using like this kind of one hot encoding style. I mean, I think that's what it's called. Basically, like for this king coin, like we have its entry here in zeros. I mean, like we're kind of like splitting it across these channels. So like all these planes, like this is like the current player's king coin. Remaining are like the current player's other coins. Then then I mean, sorry. The first two planes correspond to the player's turn. Is the current player's king coins and the current player's other coins. And then these two are kind of the same thing, but for the other player whose turn it's not. And then there's finally a plane that's basically constant throughout the whole game. That's just the obstacle plane, right? Because like there's some obstacles. That's so like if you look at the input size, right? Like what is the actual like count of like how much data are we actually feeding in the network? Well, each plane, right, is 15 rows times 20 columns times how many? 1, 2, 3, 4, 5 times 5. That's like our image stack size. So 15 times 20 is 300. Indeed. Times 5 is 1500. Yes, 1500, right? So 1500, that is a lot. That's just our input itself. There'll be a bunch of intermediate layers too. But that's where we are. And the output, let's look at the output size again. Right. Oh yeah, I realized I made a mistake that this 0 did not exist. Like 15 times 20, like let me just do it again. So 15 times 20 times 6 times 2. So like, I mean, I'm not sure if I want to include the 2 or not. Like, there are like 6 directions for each coin. We can launch it like here, 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 here. And that's 6. But then maybe we can like add 6 more for launching at half strength. But for now, let's just include the 2, right? So that's 3,600, 3,600, and then plus 1, obviously, is 3,601. So, like, 3,601. Like, not 36,000, just 3,601. So that's, like, quite a bit, right? So, like, the whole point is, like, now that we have all this information for BumperCoins, like, the neural network will take a lot of time to train. Like, when we're actually, pitting the bots, like, we pit the neural network, like the bot, against each other. Or sorry, that's the wrong pit. But like when we're actually like executing the episodes, like when we're actually like doing like the AlphaZero algorithm, like training the bots, like training this neural network it'll take a lot of time. And I want to start like with a smaller example. Like that's kind of why I'm deciding to do Connect 4. So like let's contrast the input output sizes. Like again, these are just the input and output sizes. Like they're much more like hidden layers, like other like stuff in between too. So anyways, so in Connect 4, like the input for, again, for input for BumperCoins is 1500. So let's like look at Connect 4. Connect 4. I prefer Wikipedia if possible. Connect 4. MNK. M by N. So M rows. 7 rows. 1, 2, 3, 4, 5, 6. Wait, what? Why is it 7, 6, and then 4? Shouldn't it be 6, 7, 4? Ten, 11, 10, 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's weird. I'm like so used to always seeing the rows first. Like an M by N matrix is like M rows, N columns. Okay, this is strange notation. But anyways, so the point is in Connect 4 we have 2, 3, 4, 5, 6. So in Connect 4 we'll have like 2 image stacks, I think. Like one is car player. Car player, that is like the player whose turn it is, right? Like this is like kind of like just like these two, player whose turn, like kind of same thing. Player whose turn. Player whose turn. Oh shit, okay. Player, you know what I mean. Whose turn. Like the current player, and then another stack for like that. Like let's just say that like it looks like kind of like this, right? Like you have like kind of like one, like it looks like a binary, like a 0, 1 playing like 1, 1, 1, right? And he's about to like kind of make 4, so like you'll see like kind of like a 1 here and a 1 there, kind of cutting that off. It's like you have like RGB, like right, like you have like the RGB channels. Like instead we have just like R and G, right? Like just like 2 channels, like one for like, because like in Connect 4, like just like visually speaking, we have like red and yellow. Let's pretend the yellows are green, right? Then we'd have like the red channel and then the yellow, I mean the green channel, right? So like if you just kind of forget, if you just only consider like the red channel is just like 1 for every like piece, like every location, like each coordinate, like whatever cells these red circles are placed on, like in terms of here, like you have like that, and I'll just kind of imitate this pattern actually. Right. So like this like image right here would look like something like this, like a tick mark here, 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 and then like kind of like, okay, kind of goes up, then goes down, and then there. Okay, got it. Something like that. 3, like kind of like a V, and then like that and that, right? It's like a triangle here and then there. And of course, like this whole thing would end up here. Like let's pretend that this stretches all the way here. And then something similar for like the other thing. So in this case, actually, the game's already over because like the second player like won. Okay, this is actually a bad example, but like you get the point. So like basically like each size, like each, so like what is the input size, right? Like the input size, like in BumperCoins it would be 1500, but like in Connect 4 it's much smaller. Like it's way more manageable. So like again, there are 6 rows, I think. 1, 2, 3, 4. No, what? 1, 2, 3, 4, 5, 6 rows, and then 7 columns. 6 rows, 7 columns. 6 rows times 7 columns, and then that's for one of these planes, and then the second image plane, so that's 2. 6 times 7 is 42, 84. 6 times 7 times 2 is 84. So like 84 is our input. Like that's how much input we're doing. Like compare 84 to 1500, right? And that's not it. Like it gets way better. It's not just that. Like if you consider like that's like the input cells, right? Now if you look at the output, like the policy vector output, like 3601, right? 3601 for BumperCoins, but then for Connect 4, like the policy output, right? The policy output given the state S, its size equals sorry, I don't know why I was trying to be fancy, but like the size is just the number of columns. That's it. 7. Yep, just like 1, 2, 3, 4, 5, 6, 7. That's it. Like that's it. Like if we have like 0, 0, 0, 0, because like we presumably want to put stuff in the middle, right? And like point 8 and like 0.1 and 0.1, right? 1, 2, 3, 4, 5, 6, 7, right? So like if this is like our this could be our our first turns, like in turn number 1. Like this could be like what this policy neural network outputs, right? It sums to 1. Like 0.8 plus 1 plus 1 is 0.9 and then 1.0. Like that's kind of what it does, right? So it means that we most likely want to place our first move in the center, but then with like 80% chance we'd put it here, and then like 10% chance here or here, like 20%, then we put it like 1 adjacent to the middle. That's kind of like what this represents. It's very kind of like just simple 7. If you compare 7 to like 3600, 3000, like 3.6k versus just 7, like Connect 4 is like a much easier, like the inputs and outputs for a network. Like the network will be drastically, like dramatically, like the scale is completely different. So it's like way easier to work with. So like this should be like a walk in the park, hopefully. Like training this should be really fast. So I'm pretty pleased with that. So yeah, that's kind of like the motivation. Also, like one question that like when I have like is like what kind of why I have my chess profile open is like is like so far I've like made lots of assumptions. Like I've taken my BumperCoins, which is a continuous like a game in real-time strategy game, RTS. Like whereas like AlphaZero, like Alpha Beta Search, Monte Carlo Tree Search, like all these like kind of just like Minimax, just like I mean Alpha Beta is Minimax, but like with some like pruning, truncating the trees. But like the point is that like turn-based games are kind of well studied, at least I believe that like these techniques mostly just apply to like turn-based games. I'm kind of like converting my game like by virtue of the energy system into a turn-based game basically. Like it's a real-time game, but like I'm making lots of kind of approximations. I'm discretizing the states, the game state space, and I'm also like kind of discretizing the policy vector space. Like in actual BumperCoins, you can launch your coin like 360 degrees. Like you can launch it anywhere you want with any intensity, provided you have enough energy to do so. Whereas like kind of here, I'm imposing some constraints to like discretize everything so I can feed it into a neural network. Like it's not continuous. Everything is kind of like we have hard coded like certain like the 6 or 12 intense, like the 12 vectors, like 6 directions, and then like 2 times 2 intensities. So like I'm already making some like assumptions and constraints, like artificial constraints, like just purely based on like I'm pulling these numbers out of nowhere, just trying to like see what happens. And also because of the energy system, I'm kind of like assuming that this real-time game like kind of I'm assuming that if I can train like this network to play like a turn-based version of this game, then like if I take the same neural network and I plug it in to play in a real-time like actual game, I personally think that like there'll be some like kind of positional understanding that the neural network will show, which can hopefully kind of make it at least a decent opponent to play against. And like to that end, I'd like to like kind of show a game which I discovered a few years ago. It's called KF Chess. Right. So like I've played this a few times. It's actually pretty fun. Like uh it's really I really enjoy this game. And like I haven't really played it a lot 'cause I just play chess. Like here's my chess profile. I am in fact I just played like right before starting this. I played a nice blitz game right here. So like like my blitz rating in chess is for chess.com is 1432. My rapid is 1711. So like I'm like kind of like a beginner slash intermediate player. Like I could probably crush like almost all beginners, but like if you put me up into like if you put me against like someone who's like played chess as a child, like they would crush me at like 9 out of 10 times or like always. So I'm like I have some understanding of the game. So like if my brain like is like a neural network and I'm kind of been by playing all these like games for like since 2019. Well, I've been playing on and off. So like me like for like me 2 or 3 years. I have like trained my neural network for like 3 years on this turn-based game. So like I have some kind of weights and biases in my brain are kind of like attuned to this turn-based game. Then like this is like kind of a real-time version of this game right here, right? I can just jump directly into advanced and like let's just like kind of watch me play. Let me first sip some coffee. So like right now, like I am the neural network tuned to a turn-based game, and I want to show that like I'll probably do decently against like I'll probably give my AI opponent like a good fight. So like I don't think there's any like players that are currently online, or I guess there are 2 players online. But like I'll just play against an AI. I'm not sure how to challenge players to a match. And like the idea is that like if I do well against this, like using just my neural network right here, which like just like kind of like I'm like kind of used to like playing like the turn-based chess. But like the point is that like there's like a transfer of skills, like not transfer learning, but like just like a like like this like what I'm hoping for is like kind of like once I train my BumperCoins neural networks, like play this like kind of turn-based version of BumperCoins, like when I put it into like when I kind of like in baseball, like you're kind of a bench warmer, and then like the coach like lets you kind of enter the game, like let him in. Like once I kind of like like in production, like take these turn-based bots and stick them in a real-time game. Like I'm hoping that like they won't do too poorly. Like, I'm hoping they'll be stimulating for players to play against. Because I mean, like ultimately, like why would a game have bots, right? To like help in matchmaking. Like also sometimes like players, they might not really have the nerves, or like they might not really want to play against a live player, or maybe like they want to test out some new ideas. It's easy to like kind of, at least for me as a player, I like to like I don't want to like play against an actual human. Sometimes I just want to like play single player mode just to like kind of try out some new kind of wacky ideas. And often bots are kind of good punching bags. But anyways, so like right now, again, I'm gonna like I'm used to playing turn-based chess, and I'm just gonna like show my like pit myself, like insert myself into a new world of like real-time chess and like kind of see how I do. So let's begin. Okay, we're staring at each other. So you can kind of like push pawns, like they each have like some energy level. Okay, he's like kind of he's really going all out. Okay, he's like artificially castling. Wait, can I just not? No, I can't. Okay, I'm just playing very kind of cautiously. Oh, I just lost a pawn. Okay, this is kind of bad. I mean, this guy does not seem to understand how chess works. He's like overextending. Wait, what? Doesn't that just give me a queen? Am I missing something? Just get my king out of the way. I'm afraid his rook could do some nonsense. Oh, he cut me off from doing that. Okay, fine. But can I just do that same trick on him? No, I can't. Wait, what? What is this guy doing? Wait, that does not work. I can just like... Oh, shit. Oh. No, don't do that. trying to checkmate me with his... Oh, I see, the bishop. Oh shit, no! Oh no, oh no, oh no. Wait, I can take his king, right? Okay, that was a terrible game. I'm gonna play it again. That was terrible. I mean, I just won based on I don't know. That was bad. I want to play and show some chess understanding. Let's take some space. Control the center. Wow, he's just full sending them at me. I lost my queen. Oh wait, what am I doing? Push. Oh, I see what you're trying to do. Okay, that was a bit cheeky by me. Oh, I just made myself. I'll sack it. Yeah, I'm dead. I'm dead, I'm dead, I'm dead. I'm dead. Alright, again. So maybe I should just give up and stop working on bots because I'm not good at real time. I mean, it's a 1-1. I'll just sack it, open things up. Nice try. I'll just put some of my own threats. One more threat. I feel like sacking my queen somehow. Okay, well, even if he does that... Can I pre-move it? Okay, yeah, I crushed my opponent, but I want to do it again, just to like, I mean, it's 2-1. I have 2, he has 1. I want to win, like a few more in a row. Are you gonna sack? That can't work. Cannot work. What is he doing? No, don't do that. Wait, what? Can I just do this and then can I do that on him? Oh wait, what? My queen? Let's just click jam of the position. What's his threat? What's his threat? What's his threat? Push. That's such a cheap move. Okay, yes, I see what you're doing. Okay, good. Save. I can do this then. Okay, knight controls the queen. If I'm just stick with there. Good, so he can't ever promote. Okay, well, what's he trying to do? Attack. Wait. Yeah, that was bad. Yep, I knew you. I shouldn't get complacent. Okay. I can sack, I'll sack. Don't let me sack. Wait, what? Okay, again. 2-2. This is stupid. This is actually stupid. I'll do the same exact stuff I was doing there. Is it like here? Let's just be like him and fling all our pawns. Oh no, but like then I'm not being a... I'm not being... I'm gonna like try to play for a rhythm. That's fine, I can do that and then take my knight and defend. Yep, I got you. Just make a 1-move threat. King's exposed, let's see. Wait, no, I can do this. I can do this. I can do this. I feel like I'm gonna choke right now. Okay, it takes 4 turns for my knight to reach my king, so I'm actually pretty safe. Let's just try to trade off pieces and then just calmly win. Come on, take my rook. Take my rook. Good. Oh, I can just... kind of a snake. Okay, 3-2, but the problem with this game is I was kind of learning from my opponent. I was kind of like picking up ideas like on the fly. Like once you train a neural network, like it's static. Like the weights, biases, all the parameters are fixed. Like they don't just learn more information. So I guess, I mean, I could play against the easier version of the AI maybe. Like this is currently like AI Player Advanced, but okay, I'm gonna keep saying just one more, but we'll see. Really trying to go for like an instant KO. Wait, did I just trap his bishop? Okay, he's doing some stuff. Oh wait, no, that's a fork. That's a fork. That's a fork. Wait, his king. Why is his king here? Close the position up. Good. Okay, he's actually going for such a checkmate. That's rook suck. I don't want any funny business. If he takes, I'll move my knight and then take. Let's see if he falls for it. Oh. Right. Yep. He's gonna fall for it. Take my bishop. But I wanted you to take it. If you were to go there, I just intercept. Okay, that's game over. There. Should be game. But, does he have enough time to run away? Okay, so now it's, I think, 3-2. Alright, just one more. If I win this, I'll stop. I'll try not to use like real-time tactics, because he's not making a move. I'll try to like just play like normal chess and not do anything too fancy this time. That's a bit of that's kind of a fancy touch. Oh, my king. Okay. Wait, what? Really? Sacking's fine. Yeah, take my queen. Take it. I'm okay with you taking it. I want you to take it. I can just make another one. Good. His rook is now gone. So I guess, yeah, that's the only thing I have to worry about is knight. I'll keep on light squares to avoid any bishop nonsense. Okay, he's covering that square. Wait, what? Wait, what? Where'd my pawns go? Yeah, forks don't work in this game, actually. Because like, if you fork the king and knight, he'll just move both, and then you just kind of... I can do this. I mean, yes, that is a trick. Wait, no, whatever. Let's play it safe. Because like, if I made his king, he might have been able to like dodge it, and then like... Okay, I'll just try to take his knight. Here, take my free rook and see what happens. Good, so by the time this, like, bishop will take the king, should be in time. I mean, I can push, but... Okay. Not the cleanest conversion. It's pretty much over. I can just stop right now. Just take my rook, please. He's probably gonna try to go here to like do that. Of course he did that. Just cut his king off. Keep him on the finish try. But I want to do there. Okay, so I took a lot of time, but like, the point is that like, I have like not really played this like kung fu like KF chess like at all, and like, I mean, I don't know. I feel that like a lot of my chess knowledge was kind of transferable onto this game, onto this live game. So, anyways, that's why I feel that like this whole endeavor isn't like, I feel like it's not like, I mean, I feel like it's a good idea. Like, I feel like these kind of all these kind of assumptions, abstractions, like constraints that I've imposed on BumperCoins to like make it turn-based, I don't think it's like too much of a detour from like the real-time game. But anyways, as I was saying, like, the whole point of this is that, yes, like, I do think that this is not like an exercise in futility, because I mean, I do think that like by getting neural networks to play BumperCoins, even if it's turn-based, I think that like the skills will transfer over, and then similarly, like Connect 4 like doesn't really transfer directly to BumperCoins, but like the same framework that I use to like do the Monte Carlo tree search, I want to like swap in my BumperCoins neural network and hopefully like let the remaining code just like be unchanged. And then like if I get it to work for Connect 4, I can swap in BumperCoins neural networks and like some other code, and like just kind of like the whole idea is to like extract a framework, an AlphaZero framework out of this. Like that's kind of like the goal. So okay, Connect 4. Connect 4. So let me take some gummies. Connect 4 is a really simple game. So what should I do today, like, while I'm streaming? Like, I don't want to jump into the bot directly. I feel that, like, Connect 4. Right? It's an image of it. Okay. That looks nice. I think right now I should just work on like I want it to be an actual game, like not just like a terminal. Like it shouldn't just be like in a terminal like print statements or whatever. I want it there to be actually be a web page that like shows a game. Like let me actually like build this game and let you play against the bot. So like my game BumperCoins is written in JavaScript, TypeScript, so I'm going to basically build Connect 4 in TypeScript for today. That's kind of my goal. I may not complete it, but I want to at least make some progress. I think one good benchmark, okay. Detour, Connect 4 Detour. Initially just basic like game logic and initial game logic. That's like kind of like phase 0. Then phase 1 would be oh, you can do that. Yeah, I forgot. What? One. Initial like basic initial game logic. 2, which like one I'm gonna work on right now without delay. And then what's next? Like actually make a website to play against the bot, and the bot can just make random moves to play against a bot. Bot can initially make random moves. Then 3, architect the like let's kind of architect a neural network, for our C4 bot. And 4, so after we have the network, then we have to like create like some Monte Carlo stuff to implement trees, to implement MCTS. So yeah, so the idea is to be added like generic in nature, so we can like swap out Connect 4 and use BumperCoins instead. BumperCoins like a specific code instead. Okay, so that's like kind of like the general idea, and then 5 is of course actually train the bot. I'm not sure where. Like, do I use it locally on my MacBook, or like do I kind of like go to the cloud like GCP or Compute Engine or like an EC2 instance or something, or like how do I actually like train this? So I don't want to like, but anyways, I'll think about that when we get there. I feel like Connect 4 is such a small example. I can just train it directly on my MacBook, but we'll see what happens. Okay, let's begin. Right. Let's open up a terminal. Right. Cool. Make dir Connect 4. Should I use a number? Connect 4. And nope. Okay. Okay. So users connect 4. So we have so here we like we have it, right? Connect 4. Okay. BumperCoins, right? So here's my BumperCoins, right? Here's kind of like the structure. Here's like the here's how like the BumperCoins directly looks. Let's see BumperCoins shared, right? Shared is like where like, cause like we have like a game server, a matchmaking server, and a front end server, right? It's like kind of like the 3 servers. They can run on different machines, whatever. Like, right. So like those are like the 3 servers, and shared is a pretty important directory because like each of these servers have like their own like TypeScript code, but like shared is like common libraries like that all 3 can use. So like here's kind of like shared is kind of like the core, kind of the, like the core atoms or like the core components that we work with. Like there's a move, there's a game state, there's like physics, there's like shared constants, like shared directory, shared constants, obviously, like the wind, fixed point, which is like the underlying custom number for deterministic computations. Okay, an obstacle. So like the questions like, you know, I want to like look at mirror my structure for connect 4 to be similar to BumperCoins. So I think game state is the most important. Okay, let's go back to connect 4. What? What's V is just for Vim. It's an alias. So like game state. .ts, right? So let's do so let's actually create a game state, right? Let's actually begin like now after like how much have I been doing so far? Like how many streams have I actually like done so far? Here, yeah, channel content. I have done like part 5. So finally in part 6, I'm gonna start like actually writing code. Like I've done like sufficient math to like make me comfortable. And yeah, it's actually time to write code now. But the funny thing is that this code is actually for Connect 4, not for BumperCoins. But anyways, let's begin. Class game state. So here's your game state, right? BumperCoins. I mean, sorry, Connect 4. Okay, so then what should the members be like? What is a game state and like what are the things like? We need the actual like if you look at this image, right? We need like the locations of like these cells. And what in like cells like each circle like there's 3 possible values. There's like red, blue, and then white. Like okay, so let's like kind of I think like let's have it like an enum cell, right? Like kind of like the cell, like the status, like so like an enum cell. So first of all, this is TypeScript, and like I like generally like if you look at like my kind of like leak code questions, like I typically like is there like a library thing? Like I mean like by like kind of how much languages I point is I've solved 596 questions just in Java. Like Java like wow, I solved like 1 out of every 5 questions. I only do mediums hards. I don't do easies. Easies are for noobs. So like I've just like done I'm pretty much only familiar with Java and like and I only have professional experience like with Java. So like TypeScript is a bit like kind of new to me. Like I've used it for BumperCoins, but like I don't use it that much. So like I may often like end up like looking at like the TypeScript handbook. TypeScript handbook. Yeah, exactly. Like this thing right here. Firefox suggest, yes. Classes, enums. Enums. Okay, yeah, that's an enum, right? So enum, so like what enum should we have here? Or first of all, like let's actually have a grid of cells, right? We have like so the game state will take in like a 2D array. Or like you know, first let's have some static variable. Like basically like a lot of this my TypeScript code is like kind of like since I'm like kind of from a Java background, I basically like kind of like I'm basically trying to write Java code or like I'm like kind of taking a subset of TypeScript just to like mirror Java. So like we have like num calls and we have num rows. So again, the number of columns I believe was 7. Number of rows should be 6. Just double check. Yep, 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5, 6. And num rows should always go before num columns since m by n. Okay, so we have that, and now let's have like a 2D array of like cells. So like all these circles, right? We need to actually like have an array of them, right? So we have like so like static are just kind of like so now we have like member specific things. Like this is the actual game. Oh, we also need to know like whose turn it is. Like is it player 1's turn or player 2's turn? So let's have a or wait, how do you like declare? I mean class. Okay, let's see a class. Getting started. Yeah, let's do getting handbook. The basics, yeah, classes. Classes, member visibility, public, static, yeah, static. Just static name. Okay, so then what about like public, private? Okay, one thing I can do is I can actually just like, let's just save that and let's actually look at some BumperCoin code, right? Like, less shared coin, right? Okay, so like you just have an export and then you have like a name and its type. Name colon type. That's the syntax. Okay. Okay, that sounds good. So instead of like let, because like let is like not like we're in the context of a class. So like is P1, right? Is P1 turn? Boolean. Okay. So like we need to know whose turn it is, and then we need to know let's call this our grid or our cells. Yes, our cells. And what is cells? Cells is a 2D array, right? Of like cell. Right? TypeScript 2D array of objects. Oh, I've already looked at this apparently. Thing colon. Yep, that sounds good. Thing colon. Okay, yes. So this I'll actually copy this whole thing right here. I don't think that's stealing code, but yes, I've stolen this guy's code. Oh yes, I have to use the this. I have to use the this in Java. In Java, I'm not. Anyways, cells. So it's only a single thing, which is an empty list, right? That's pretty much it. Or actually, no. We have to actually like create the cell. Okay, so then now's a good time to actually like consider what the cell is, right? There's like 3. It's like not like a boolean with 2. It's more like 3. So that's why we're using enum, not like a boolean. So then we have like we have a vacant. We have P1 owned. P1 owned, and then P2 owned, right? Fair enough. So initially what we do is we're going to like for int I equals 0, or okay fine, r equals 0 for r for row, r is less than num rows, r plus plus. We're just going to initialize this our cells, right? Something like this, right? Let's copy that, paste it, and make all the RC for column, right? And instead of num rows, num calls. Then we're going to like do a let like a row, right? Sorry, we should do it outside the context of here, like here. What? Let row, so the row is just an array of cells, correct? Yeah, just cell. Just let row equal to just like a new list. And then for each of the columns, what we're going to do is we're going to do row.push. And what exactly are we going to push? We're going to push, what are we going to push? We're going to push a new cell, right? Yeah, just cell.vacant. Cell.vacant, oops. So to recap, this dot cells, and then, so we have the row, and now we have to do cells.push and add this new row that we just built up, right? So does this make sense? Our constructor, actually, let me just quit this and actually like see if I can compile this code, right? tsc.ts. Huh. Oh, it's not Java. I have to replace ints with lets, right? for which line was it? Line 10. Okay. Script. That's right number. Let stop equal to 0. Okay, yes. Okay, yeah, that seems good. Let's run this. And let's do the TSC whatever. 3 errors. Yes. Yes, I forgot all the stuff, like the name, wait, how did I get such a big whatever? Okay, lines 10, 12, 15. Okay, this is too cluttered. Let's add some space. Okay, that looks good. I'm missing something. Yes, this dot cells. Okay, let's check that. 2 errors. Oh yes, it's not this. It's a static thing. I have to actually like. Okay. Of course. Right. We just have to like. Because like this would be if it's non-static. If it's just a normal member. Like this dot cells. Okay, now let's just make sure that doesn't have any problem. Okay, good. So now if you click ls, then we see like we have a new file, gamestate.js. Okay, let's clear. Too much stuff going on here. Okay, so we have a game state, and we have initialized so then in a constructor we have first like kind of instantiated, like just said, hey, like cells is a new empty list. In this for loop we want to populate it. We want to like actually fill up, we want to actually like create a 2, 3, 4, 5, 6 by 7 grid here. So then we have like, so for r equals 0 to num rows, we're going to add 6 rows. And for each row, we basically fill in like num calls cells. Okay, that seems completely fine to me. I don't see anything wrong with this, so I think I could just get started then. So here's your constructor. That's a good. Actually, here's a good point to actually like do a get. Like let's actually do a get init get status. Oh yeah, well, let's delete all the JS. We don't really care about that. So let's do a .get ignore. And let's ignore all the JS files. Status. Okay. Get add all. Get status. Get commit. Initial commit. Get status. Okay, that's a good place to start. Now, actually, one thing which I could do actually is I have like a BumperCoins code somewhere here. Get BumperCoins, GitHub. Right. How do you push again? Just get push. Specify URL from command line, or can I sign in? No, if I do that, I'll leak my password. Okay, well, I'll do it. I mean, can I sign in from Google somehow? Because I don't want to leak my password. Okay, forget it. I'll just push it later into my own time. So for now, yeah, let's forget about this GitHub stuff. Yeah, but anyways, like there is like this kind of cool like fixed point library that I wrote. But anyways, the point is that like all open source code from like related to BumperCoins is gonna be like in this GitHub profile. Like if I do open source the game, you'll find it here. Right. Okay, I've already seen how to. Okay. Right. Right. So okay, so we have our game state, right? We have our game state. Get status. Okay. So now, like, what should we like? Let's just look at my BumperCoins. Like, that's a good idea. Let me just kind of like, last shared game state, right? Game state. TS. Okay. So here's my BumperCoins game state, right? It has a game board. It has coins, an array of coins, wins, all the properties. Refresh just got like kind of that's irrelevant here. Is game over? Okay, that's an important one. So basically iterates through all the coins, and like if it finds like a coin, like wait, can I just do fixed point less than equals? I have or less than and equals. I can just do fixed point dot less than or equals. Okay, but the point is that we're just kind of like searching for a king that's like a king coin whose health is 0 or less. Like initially I had this code, but I converted everything to fixed point, right? And outcome. Wait, so these two are kind of like again, you're iterating and like kind of searching for if it's king. Like this code is a lot like this. So I guess we can consolidate this. Like these two, like kind of like this one says is the game over Boolean, and this one outcome returns a game outcome, which must be, I think it's an enum. So game outcome, like player 1 won, player 2 won, draw, player 1 forfeit, player 2 forfeit, player 1 left, player 2 left. Because in my game you can forfeit, and sometimes like just the connection is lost. Someone just closes the window because they don't realize you can just double escape to forfeit because they're not trying to navigate and like escape the page. So I have lots of enum. So I think that like, and here's a game board, but like, I think that in Connect 4, like we don't have to worry about people leaving because it's just you and the bot. That's it. And there's like, let's have no forfeits. So we only have to care about like these 3 outcomes. But then we can kind of combine these since they do the same thing. So instead of outcome and game over, we can kind of merge these in Connect 4 to be like game status, where like they'll be like player 1 won, player 2 won, like terminals, and like player 3 draw, which means like those are like the terminal conditions. The leaf mean like the terminals, and also ongoing. Okay, so that's next. And we should also implement this method. Okay, perfect. I got it. So then we'll have this, right? Let's go back here. Let's actually copy this, and we'll take this, right? And we'll kind of like do something similar to this. And then enum like game status, right? Game status. So then game status would be like, again, like P1 1, P2 1, then drawn, and then actually this should be the first one, right? And then ongoing. Okay, ongoing. So here's our game status. So now what we should do for the game state, let's have like a function, like let's call it like, let me look at BumperCoins again. We have a static outcome. Why is it a static? Like, why is it not just a? Why is it a static? Well, I don't really care. Yeah, only to be called after is successful game over check, because we're assuming that we're already over, but now we're not. We're kind of consolidating these two. Okay, I'm just gonna copy this, like actually copy it. Right. So then here, let's just kind of copy that and like paste it. Static. Then this, like our enum's called game status, right? So then let's call this like get game status. Takes in a game state, and then it returns a game status. Okay, finally. Now here's like, so then here's like the thing, game status. So we want to like kind of know what the game status is. So then how do we know the game status? Like we have to basically iterate through the entire like cells. And we want, if in fact I'm getting tired, so after I finish this, I'll just stop and make sure it compiles, and I'll just like call it a day for now, or call it a session for now. So now like we have these cells, right? So how do we like, we want to like, given this, we want to know the game status. So here the game status would be ongoing because like no one has made a 4 in a row, and it's still ongoing because like there's still at least one empty cell. Like if everything were filled up and no one has got that, then it would just be a draw. So those are our 4 cases. These are our 4 kind of our game status, right? It's like we kind of like, we know what this kind of, so given the game state, like, actually no, there's no need for this to be a static member. Let's just kind of, yeah, just like do that and like use this dot whatever. So then there's no need for like this. There's no need to actually feed that in. Just game status, right? For our current game state. Okay, so how do we do this, right? Well, we have to check all the rows, all the columns, and all the diagonals. Right. Okay. So like, okay, so here's actually like a little bit of like a trick, which I've like, I mean, like you could like, how do you actually iterate these diagonals? Like there's like I think I've done a leak code question recently like that. Low battery, okay, I'll plug my battery in. Cable. Okay. So there's like, at least to my knowledge, there's like kind of 2 ways of iterating over diagonals. Like one is like breadth first search, like you put this in your queue, the next level you have these 2, then these 3, then these 4, 4, 5, 6, 6, 5, 4, 3, 2, 1, and like kind of do that. But one other kind of technique that like, there's like a nice, really kind of like nice, I think it's called like, in leak code it might be called n queens or something, but like, or like, I think n queens maybe. Queens. The point is that like there is a technique to like iterating, or like there is like one kind of technique to determine like which cells are on the diagonals, and that is like a really nice one. Let me just create a new board. Refresh. Or does it give me the old one? Okay, so it still remembers. Okay, let's just kind of set that aside. So like if we have some cells, right? Like, okay, this looks terrible, but like we have like something right here, right? Now, how do we know, like, let's say that like we're given like this, like, let's just say that like we kind of like have this cell right here, right? Its coordinates, it's like 0, 1, 2, can't write, 2, 3, and like 0, 1, 2, 3, 4. And as always, everything is in the form r comma c. That's kind of like how I do things here. I always do row first. It might be a bit counterintuitive since some people are used to like x and then y, but like for me, like it's just r and c. So this index, like its coordinates are like row 2. That is the 3rd row because there's 0 indexing, column 0, so 2, 0, right? So now like given some like x, y, right? Like if you have like some like r comma c, sorry. If you have like some r comma c, right? How do we know that like they share this diagonal? Because if like this is like if like this is I comma j, right? Like I comma j, then this cell right here is I minus 1, right? The row is like I minus 1. So from row 2 it becomes row 1. Then column j plus 1, right? So one like little trick that you have actually is you can take this I and this j, you can add them. So like I plus j, right? And then -1 plus 1 cancel out. So everything on this diagonal, they're like all cells on this forward diag, have same I plus j score. Again, like I did like some leak code question involving like chess and like having I think like a queen, like some like queen right here, and then like I had to like kind of like determine like I had to like consider all the cells in the immediate diagonal vicinity. I believe it's like a bishop or a queen or something. I think like queen, And like I discovered like this little thing right here for forward. And for backwards, it turns out that you can use a I minus j or j minus I. It makes no difference because like these map to like one diag, and then j minus I is just -1 times that. Like it makes no difference which one you do. I mean, I could derive that like if you have like some like cell at like k0, right? If you have like some cell like let's say k0, now I'm doing the backward diags, right? If you have some cell at k comma 0, right? Then like a generic cell on the same diag, it's like it would have like IFJ, like its RC values would be like you have like k, right? Like so this is like this your row is k. So to get here, what's your delta column? Like from this row to this row, right? Like you have like I plus some delta column, right? Because like to get from here to here, like the rows kind of delta row, what am I doing? So you have like some delta R for row, and then you have also some delta column. So you have like I plus delta R, and then we have like J plus delta column, right? So like if you're given some like I comma J, right? Then like you can also have like I plus delta R, I plus delta C, where such that like where delta R equals delta C, right? So in general, we can kind of make this like I plus like some constant, and then J plus some constant, right? So if we do I minus J, instead of k comma 0, we can just like make it some I comma j, right? Like that's some I comma j, like right here, and that's this. Then I minus j, that's like it gives you some score. Let's call this like S, right? So then here, the score for this, like for like the score for S of I comma j, right? If I why am I doing that? If this cell here, like the score of this cell is like, let's just call this like cell A and like cell B, right? So then like S of A equals I minus j, and S of B, and let's just like the score of any cell I comma j is defined as I minus j, right? I minus j. Then this score, if you plug this into like this formula and this formula, then these like I plus is like I plus this constant C, this delta, minus J plus C. And the whole point is these C's cancel out, right? So this equals I minus J, because this C and that one, the negative kind of distributes itself and we cancel out. So the point is that S of A equals S of B, right? So I minus J basically, like, so I minus J is for backward, is a score for backward diags. For backward diags, like the backslash. And then I plus J is score for the forward diags, right? So like now we can like do everything, right? So then like here's kind of like the overall kind of technique, right? Like initially like we want to like kind of like do rows, do calls, do forward diags, and do backward diags. So this is kind of like the idea. Okay, so now like the question's like, how do we actually like check? Okay, first of all, I have to use the restroom, but I'm just gonna hold off on that. So like, I'm gonna start by saying that like the number of cells in Connect 4 is super tiny, right? Like it's only like 42, like 6 rows, 7 columns. So it's like not such a big. Wait, what is it not? Oh wait, I have to plug in my adapter. It's not really plugged into power like the socket. Oh wait, I have some oatmeal left over. Right. Okay. The point is, we have only 42 cells, so like, it's okay for me to be a bit inefficient. Like, this is just like a toy example. Like, I don't really care about like being as optimal as possible. Like, I only care for that for LeetCode. But like, when I'm actually doing something, like, I'm more interested in correctness right now. So I may do things inefficiently, but I just want to like have everything be nice and readable and understandable to me and to maybe others, but mostly to me, because I don't really care. So, anyways, yeah, it's important to I mean, I think that if I can understand it, almost anyone else can understand it. Just because, yeah, that's what I think. Okay, so let's just have like some function. Let's have a nested function, JavaScript, or a private function maybe. Like a private function, just like kind of a helper function. Yeah, it's define. I mean, I don't really care about like efficiency. I'll define it each time. So let some function or let's give it a name, right? So let's have like a helper or like basically my idea is like, again, this is just for my readability, is like it'll kind of like take in, like we have like first we check the rows, we'll put all these rows into like lists and we'll check each list, then we'll kind of like go this way, then we'll go that way, and finally we'll go that way. The point is I'm saying that like we have to check all of these entries as a list, all of these entries, all of these entries, this list, that list. So like the point is like I want to consolidate the logic and like have some general function that's like take in this list and like kind of tell me like, hey, do we have like 4 in a row, right? So let for in a row checker, right, equal to like it'll return like Boolean, right? Or actually no. Let 4 in a row checker equal, let's just return a 4 in a row checker equals to a function that like takes in what? Wait, hang on, here's some noise outside. Okay, so basically 4 in a row checker is some function, and like it will basically take in a list, like a cell list, which will be like a cell like that, right? It'll take a list of cells, a cell list, and what will it return? Let's just have it return a game status for now. This is like completely arbitrary. Like if it returns player 1 1 or player 2 1, then like I will just return out of this function. If not, I'll just keep going. Okay, so then and then one precondition, just like a helper function. Let's see, a precondition. Precondition is cell list is not empty. Cell list, precondition cell list is not empty. So then okay. So then let the initial cell let's have this like kind of like, let's kind of store the current cell we're on, like, or like the current stretch we're on, right? And let's store its count. So let's cell, and initially this will be the first cell, and we'll just iterate over everything and change the counts and do the same thing. Like, yeah, that's the idea. Like maintain the stretch, this stretch. Like there's like kind of a contiguous segment. Like we see like player 1 coin, and then player 2 coin, and then we switch it. So it'll be like kind of a stretch of 3, and like that's kind of like my idea. Like basically the idea is like we kind of like we kind of take this like huge list, like this list of cells, and we break it into like segments, like based on like the coloring of it, where the coloring is like which cell it is. Well, I'll just write the code, that'll show my thought, but like, so let's have like the cell just be a cell. And let's initially have it at like cell list of 0, right? And let's have a count is a number, and that'll just be 1 for the first one, right? And then for let I equals 0, I is less than cell list dot length, I plus plus. No, technically we don't have to start at 0. We have to actually start at 1, because we actually accounted for the first one, right? We accounted for it right here in cell list of 0. Okay, so now let's just call, we can't use cell again. We have to use like some, let's do cur cell equals cell list dot I, right? There's 2 cases. If cur cell equals, because it's an enum, we can just equals it, equals cell, else, or instead of else, we can just kind of like do like a continue at the end, right? So if we were here, then it does not equal, right? So like, if the cur cell equals the cell, or actually let's do the other case. If it does not equal the cell, if it does not equal the cell, I forget, let's do an else. I was thinking of doing continue to avoid one level of nesting, but I don't really care. So the current cell equals the cell, then we kind of like reset the count, right? So cell equals cur cell, right? Because now like we've like swapped. Like if they're player 1 owned, like now it's a vacant, then like that. And the count again equals 1. I think that makes sense. And now like in this case where they match, then we extend, right? So then count plus plus. And now, like if count, this is a crucial part, is equal to 4, if the count equals 4, and at the end of everything, let's just return just a game status dot ongoing, I think. Let's see the options. Yes, ongoing. If the count equals 4, and the cell is not equal to cell dot vacant, right? Because like if an actual owner owns it, then let's actually return, right? Then we return the cell. If the cell equals p1 owned, cell dot p1 owned, then just game status dot p1 because we found 4, and then or else same thing but for player 2, right? So that's pretty self-explanatory. Okay, I think we're done with this general check, right? Let's the end for here for now, let's just call this return game state dot. Let's just see if it compiles. I see. Take that and return a game status. Okay. 26, right? 26 GG. So it takes in the cell list and returns a game status. That should be it. 2 errors. Like too many. P11 does not have type of game status. Okay. Caps. Okay, that's okay, fine. Typos don't count as errors. in my book. Nice, 0 errors. Okay, so now that we have this helper function for in row checker, all we have to do is like populate it. So then for I think it's let, right? Let row of this dot cells. So let row result, which is a game status, equal to whatever this function is, 21 GG of row. If row res is not equal to game status dot ongoing, then we just return the row results, right? Let's see if this compiles. Nice. Okay, now let's do it for the columns, right? 48. The calls. Okay, this one's a bit more. It's like we need like the loop, right? Because like, let's kind of copy this, right? Gonna copy this kind of general 2D loop, right? And paste it here. Okay. So now R and C specify what? They specify the actual like cell in our 2D grid, right? So basically, now we have to like, in fact, let's actually invert this, right? Let's invert this. Whatever's in here, we delete. And we place here. Because we have to do it like in terms of columns first, right? And now that should be in the buffer. Exactly. Save that. So now we're doing it in terms of like columns on the outside, not the rows, right? So then for each column, what we want to do is we want to like build a cell list, right? So let our cell list, which is an array of cells, equals to this, right? And now we're going to populate it here. And once we do that, then for the column, we want to kind of do the same thing here, but instead of row as col res, right? Something like that. Like col res, right? So in col res, instead of like that row, it's going to be the cell list that we're going to populate. The col list is that, then of course we have to return the col res. Okay, that looks about right. So all I have to do now is populate this the cell list. That's what we want. We want to populate that. Okay, so then cell list, right? Dot push whatever the cell is, right? This dot cells of RC, right? The row and the column. And we do this for all the columns. I think that's it. That should be right. That should be the column ones. Let's just make sure it compiles. Good. Good. What else? I'll check the air quality. Actually, I'll check that later. Right. Now for like the hard stuff. The forward and backward diags. Okay. So what I need to do right now is like kind of like the same technique I just kind of talked about here. I plus j, I minus j. So I need like some sort of map, right? TypeScript, map, like multi-map, or a map of number to a list. Something like this. Okay, perfect. I'm going to copy this right here. Tuple. Define products. Map. JavaScript map. Okay, I have it already. JavaScript map. Value is list. Okay, I feel like this one more. So let's call this like score to diag is a map of like, again, our score, like our diag score is just a number. And then we're gonna have all the cells, the cell in that, right? So now, same thing, we have to kind of like do column first, I believe. Something like this, let me just copy that right there, and then paste it here, and then, right? So now, m equals 0. I mean, this sense like column row really doesn't matter like which order we're doing it. It really makes no difference if we do column and then row or row and then column, but I'm just gonna do it this way. So now then like we have the cell, or it's like Java. Let the cell type cell be this dot cells of the row and the column, right? Okay, so we have that. And now let's let score of the cell to be R plus C, right? Just the row plus the column. I don't know, this is visually just annoying me, so I'm gonna actually invert the order again. And I just really annoying me. Okay, so like that, the row and then the column. We got the cell, we got the score. So we have the cell and the score right now. Then if the map to TypeScript or JavaScript map, like is there like a put if absent thing like they have in Java? That's JavaScript. So we kind of put that like, what do you call it? Like that thing that forces Google to like find the exact match, right? Okay, so if score to diag dot has, if it doesn't have, so score to diag does not have let's add some more space there to work with. So if the score to diag does not have score, right? Specified key, like JavaScript, Java would be contains key. So then if this does not have our score, then what we're gonna do is we're going to map dot, how do you add them? Put, wait, there's no map dot put, wait, what? Set. Set key value. Do I have like an example? Okay, perfect. Let's set that. Okay, so map.set key value. Okay, then what we're gonna do here is So we're gonna do score to diag dot set the key and the value. Okay. So the key is just gonna be the score, right? And the value is just gonna be an empty list that we're gonna build up on, right? Just an empty list. Okay, so now we know that the map has this key, right? Then what else does the map have? The getters. Get the get key, perfect. Then just source of diag dot get the score, which gives us the list, dot push the cell. Just that. Perfect. Right? In fact, we can actually do the same thing for backwards, except we just change the score function. I mean, I could in theory just actually like kind of yeah, I can do them together. Why should I do them differently? Do forward and backward diags together, right? This would be, instead of like score, let's call this a forward score. Score to diag forward, right? I can have the same thing but for backward. Backward, right? So then score forward score forward okay. So right here, what we've done, we've got the cell, we've got the forward score, and then if the forward map does not have the forward score, then we kind of add it to new list, and then if not, then we like, and then now that we know that it has the key score forward for forward map, oh yeah, this should be let's take the word forward. Okay, that looks about right. Let's actually check, and then so now we have like kind of made sure that the score, if it doesn't have it, then we kind of populate score forward in initial list, and then we just like push the cell. Right, the cell which corresponds to score forward, right? Okay, let's check if that compiles. Okay, of course. Try changing lib compiler option to ES7. Some compiler flags, I think, right? I think I have something. I had ran into this issue before, and I kind of fixed it. GitHub BumperCoins fix.js, right? I like exactly. TSC. Just copy that. Let's just copy it directly. In fact, good. No errors. Just to show that again. Slow motion. Yep. No errors. All right. So now where were we? Right, so I did everything for score forward, right? Everything was done for score forward. Now let's just do it for score backward, right? Score backward. Backward is like, now the key difference is R minus C. And then let's just kind of take this here and copy that. And then kind of make this backward, right? Backward. Okay, so the score, so basically I took forward, made it backwards. So the score to backwards does not have the backwards score. Then we just populate it with an initial list, and then same thing here. Now we know it has the key of the backward. Then we get the score backward, and then we add the cell. Perfect. Okay, and then now how do we iterate through the map? TypeScript, I mean, how do we iterate through them? How do we iterate? Like JavaScript, you have like entries, so we iterate the entry set. Iterate entries of map. I don't want to use an arrow function. That just looks like the for each. No, I don't want to use that. ES6. I definitely saw that somewhere. Yeah, ES6. Okay, perfect. I can just use that then for sure. For sure. Okay. So now, let's do the forwards. Let's our pop do forward. Call this populate forward and backward diag score maps. Then like now like actually do forward. I mean, I don't really have to comment everything. Let's undo everything. Just do forward and backward diags. Yeah, sounds fair enough, right? So let's do the forward ones first. Let's copy and paste this code, right? This seems pretty nice. ES6, okay. So then okay, so now our map would be the forward one first, and then we can copy paste the next one. So this key would be the score, and then the value of this map is of type cells. Cell list. Let's call it cell list again. Then basically same thing here, right? Kind of like exactly what we did like somewhere up here. How we actually call the helper function on it. Nothing too different. Just I don't know, let's call this res. But now for in a row checker, yeah, perfect. In fact, that's exactly right. So then that's like the forward, and do the exact same thing for backward. So then the res game status is for in a row checker of the cell list for each of them. If the res is not ongoing, that means player 1 or player 2 definitely won. Then we return res. And then, okay, so now that we reached here, we know it's not p1 game status dot p 1 2 1. I think it's all caps. Need to check for draw. Okay. So now, oops, what am I doing? Sorry about that. So now, like, to check draw, I mean, technically I probably could do it, like, in some other loop, like, okay, this is, okay, whatever. So then, basically, like, I feel like I'm just going to, like, iterate, like, even though this is probably, like, not optimal, well, none of this is, but, like, I'm going to, just iterate over it again. Like what I want to do now to track if it's draw, because we know that, like, no 4 in a rows have been found, is that we just, like, want to see if we find a single vacant cell, and then if we do, then we're done. Right? Actually, I realized something. We don't actually have to check every single cell, right? Because of gravity, we only have to check the top what our num column cells are. So top 7 cells. If this is empty, that's empty, that's empty, that's empty, that, or like if this is full, and 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 this is full, right? That means it's a draw. Why? Because if anything is full, then by virtue of gravity, everything below, like when you plop a coin, it falls all the way to the bottom and it connects 4. So like the point is that, like, if we have something filled here, that means necessarily everything below is full. So all we have to do is check the first row. That's it. Okay, that's perfect. So okay, so then to check for draw suffices to check the top row because of gravity. That is, a coin in top row implies all coins below, all cells below are populated by coins. Again, the assumption is our game state is a legal game state. Like, it's not like some coins are floating. Like, yeah. Seems game state is legal. Okay. Then for let's sell in what? In this dot cells of 0, the first row, right? So for each cell in that, what we do is if cell equals to cell dot vacant, then we return. Then we just do this, right? Then we just take this here. Like that's wrong. That should be in the bottom. What we do is we return draw. Drawn, I think. There's an N there. Let's double check. Indeed, it's, wait, no, it's not. Wait, do we know? Yeah, DRAWN, drawn. So basically the idea is that, like, is this correct? Finally got indentation correct. So then for all the cells, okay, let's delete all this empty code. For me, 8DD, 3. Okay. Let's kind of clear all this stuff here. Okay, so then what is this loop doing? So then for all the cells in the top row, so then the moment we find a vacant cell, right now, again, if we know here, like P2 and P1, like there's no one. Like not all of them. Like the point is that like right here, right? Basically, we're checking to see if there's any vacant cell. The moment we find a vacant cell, we say it's ongoing because like there is some room for someone to add something new. So the game's ongoing. So now if we have exited this for loop, that means that all the cells are not vacant, right? That means that like they all have some coins. And since they all have some coins, there's no more space to add any new ones. Therefore, the game is drawn. Okay, I think this is done. Get status. Get diff. What is this nonsense here? Game state ongoing, get game status. Let's just fix that. Get game status. Get game status. Let's delete this extra line. I think that's the issue here. Clear. Get diff. You press J to go down. Okay, that looks good. Get status. Get add all. Get commit. Add. Oh, sure, no, wait, sorry. I have to first check if this actually compiles, right? Okay, it doesn't compile. This dot cells. Oh, it's let's sell off. Okay. Line 91. 91 GG. ZZ to center it. For let's sell off that. I think, yeah, that should be correct. Check it again. I just want to use the restroom. Score 2. Rated using the down level with a target of ES 2015. What is my compiler thing? 2015. Okay, if MDN says it, I'll just do it. I really don't want to use this lambda or this arrow function. I really don't. Okay, they're representing map as an object. That seems a bit too out of date. Not fastest, for each. I don't care about your opinion. For I'm so annoyed right now. Just want to use the restroom. What's this error message called? Down level iteration flag. Yeah, I don't want to read that. Target. It'd be nice if there were not so many different versions of these things. Okay, fine. I'll just use a for each function. Actually, wait, no. Okay, fine. Fine. I'll use that. Whatever. They're forcing me to have no choice. I don't know. Just want to get this done with. So we have a score here, right? The score, which is a number. And that's like the value, which is the cell list, right? And its value is a cell array of cells, correct? And so now that's been bound. My map dot for each, so then the map we're working with is this one. And whatever code we had inside this map, that's kind of like binding to score and cell list, we kind of bound it there. So we can just take everything here, just delete it and put it there, then get rid of that junk. And take this entire thing right here, right? And kind of copy it, but then for backwards. So now we're iterating over this one, right? Then for each score to diag again, like everything, all the cell lists are tied to the score. Then whatever we do here, right? I mean, wait, no, this is the same thing. Like, it's already correct. Like these three lines are actually visually like they're the same as those three lines because like it's the same exact thing. The only difference in for and diag is like this score right here. Once the map is populated, it's all the same. So we can just delete all of that. I think we're ready. Cause it's like how are these scores populated? Wait, there's a mistake. No, we can't invert it. I have to actually do columns first, right? Like, if I do it in terms of like, wait, right? So here you're mixing and matching the columns, but like when we're considering like wait, does it matter? Does it matter? If we kind of go here by here, by here, by here. So like we do this row first, Oh, that should be the same thing. We do all these rows, right? Like rows and then columns. Like we kind of go here, 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 so forth. So let's just kind of work it out. So you find a cell here, a cell here, a cell here, where we register all these cells as scores. And then here, for forward diags, this one would be its own thing, because like there is none of that. This one, hey, we found it. This one, this one, this one, this one, this one. So this one would do all the backward diags here. So like, say we have like this backward, this big or like, so let's say this backward diag, then like we kind of iterate through here, and we would find the backward diagonals. Like the backward diag list for this diag would like have this in this specific order, right? But the forward ones I think probably is reversed, right? Like, yeah, like we kind of like search, like we end up like searching like this one, this one, this one, like in this order. Like that's what the cell list would be for like this backward diag. But for forward ones, like let's say like for this one, right, we kind of add all the scores for like the top row. And then for this one, like we said, this one has it, like this one would have like the score here match this. So like this one would be added to cell list for that score first. Like this would be 0, like this would be like row 0, column 4. So -4 score, -5 score, -6 score, -7 score, right? So like -4 score. Then for here, it would be also -4 score because, no, sorry, forward is plus. So score would be 4, like 0 score, 1 score, 2 score, 3 score, 3 score because 0 index, right? So this would be a score of 3, 4, 5, 6, whatever. And we're here, again, score of 1, 2, 3. So then basically like the cell list, like for the backward map would be like in order, like from like here to here. But then for forward, it would be reverse. But if you have 4 in a row, like say like this, right? If you have like these 4, it doesn't matter if you iterate like from the backwards, from the head or the tail. It makes like no difference. Like the count would still be the same. So I don't think there's any error here. So I think that everything is good to go. Okay, let me just save that. Get status. Again, everything is, wait, what? Let's just add this stuff. Add but not commit, right? Get status, yeah, just get logs. We have the only initial commit so far. Just the initial commit. Okay, now let's test our thing. Of course, there's some errors. Argument of type score, this lambda function is not assignable to types of parameters, score and value are incompatible. Let me just look at line 76, see what I'm doing wrong. 76 GG, ZZ, score. Score to diag forward, that's a map of number and cell array. Number and cell array. I don't see what's wrong with that. What? Argument of type so score, like the lambda we pass in is a function that takes in the score and then a list of cells, and it returns 1, like it turns pair 1, pair 2, or turns cron. It's like some subset of game status values. Game stati, if status is plural of statuses, stati, yeah, statuses, game statuses, is not assignable to parameter. So here's what parameter expects of type value cell key. Oh, the value is first? Wait, what? Oh, the value is first and then the key. That is odd. Okay, the value comes first. I did not, that's very unintuitive to me. Okay, something like this. We swap the order, sell list and then score. Same thing here. We take the sell list first, and then the score. Okay, let's check that. Great, no errors. Let's do it again, just because I like to see that. I like to see no errors. Status, get add all. Status, get diff, cached or staged. I think staged. I think they're the same thing. Staged. Okay, so I deleted. Wait, what's this extra line right here? Get game status. Maybe this delete that line right there, because like that's just an empty space. Okay. Get status. Get diff. Delete that line. Clear. Get diff and then staged. Reverse search that. Okay. Alright. I still see a line here. I don't care, whatever. I don't care. Game status. Okay, so I basically kind of like, the whole point of like these changes is to like do the get game status. Get game status. Okay. Status. Get commit. Initial implementation of get game status. Initial implementation of get game status. And then let's just do like kind of untested. Okay, initial implementation of get game status untested. Of get game status. Status. Okay. Okay, I think we're done, and I think it's a good time for me to stop because I have to use the restroom. So yeah, that's all for now.